Today's lesson is on how do we solve linear quadratic system of equations. If we remember when we learned about system of equations, a system of equations is two or more equations that have two or more variables. In this case, we're going to have a linear quadratic system. That means one equation is going to be linear and one equation is going to be a quadratic. We are still solving them the same way. We're going to have to find an x and we're going to have to find the y value. So the first problem says to solve the following system of equations. Y equals x squared minus 2x minus 3 and y equals negative 5. Take a second to copy down the question. So when we're solving linear quadratic systems, we're going to use our substitution method. So if I look at my second equation, I have y equals negative 5. And then in my first equation, I have a y up here as well. So I can take this negative 5 and I can substitute it in to my first equation. So I could have negative 5 equals x squared minus 2x minus 3. Now in order to solve this a quadratic, now I just have a quadratic equation, I'm going to see if I can factor. So my first step is to get it set equal to 0. So I'm going to add 5 to both sides. I have 0 equals x squared minus 2x plus 2. Since I have 3 terms, I'm going to use my AC method. So I multiply my first and my last. When I multiply them, I get 2x squared. The numbers that can multiply to give me 2x squared are 2x and 1x, or negative 2x and negative 1x. Neither one of those two options combine to give me this middle term of negative 2x. So factoring is not going to work. So now I'm going to solve this using my quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to identify my a, b, and c. My a is 1, my b is negative 2, and my c is 2. So I have negative, parentheses, negative 2, plus or minus the square root of negative 2 squared minus 4 times 1 times 2 all over 2 times 1. These double negatives turn into a positive, so it's 2 plus or minus the square root negative 2 squared is 4 minus 4 times 1 times 2 is 8 all over 2 times 1, which is 2. When I simplify, I have 2 plus or minus negative 4 over 2. I am not able to have a negative under my square root, so this system of equations has no solution because I cannot have a negative under my square root. The second problem, solve the following system of equations. Y equals x plus 2 squared minus 6, and y equals 4x minus 2. Take a second to copy down the question. Same method, I'm going to solve this using substitution. So I have y equals 4x minus 2, and then I have a y in my first equation. So I can substitute into my first equation. 4x minus 2 equals x plus 2 squared minus 6. So now if I look, I have 2 x's in this quadratic equation, so I'm going to have to simplify and solve it. In order to simplify this x plus 2 squared, I'm going to have to multiply it out using the box method. So I have x and plus 2 and x and plus 2. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. And I combine my like terms of 2x and 2x. So this gives me x squared plus 4x plus 4. And then the minus 6 comes down. And I'm left with this 4x minus 2. Now I'm going to solve this quadratic and see if I can factor. So I'm going to set it equal to 0, but before I do that, I need to combine my like terms. This negative 4, positive 4, and negative 6 gives me x squared plus 4x minus 2. Now I'm going to set this equal to 0, so I can subtract 4x from each side. I'm left with negative 2 equals x squared plus 4x minus 4x, just cancels out, minus 2. Now I'm going to add 2 to both sides. This cancels out. I'm left with 0 equals x squared. Negative 2 plus 2 cancels out. So I just have 0 equals x squared. All I have to do here is take the square root, and I get that 0 equals x. And now, since this is a system of equations, I need to solve for y as well. I could pick either equation. I'm going to pick the linear one because that's easier to work with. So I have y equals 4x minus 2. I'm going to substitute in my 0 for x. So I have y equals 4 times 0 minus 2. 4 times 0 is 0 minus 2. And 0 minus 2 is negative 2. So my y value is negative 2. So I can write my solution as an ordered pair. It would be 0, comma, negative 2. So this would be the solution to this system of equations. And the next problem. Solve the following system of equations. 5x plus y equals 2x squared plus 6. And y plus 4x equals 7x minus 2. Take a second to copy down the problem. If I notice in both of these problems, I do not have x equals or y equals for either problem. I need to turn one of the equations to be y equals or x equals. If I notice in each problem I have an x and an x squared, I have an x and an x. So there's a lot of x's. So I'm going to get y to be by itself for one of these equations. If I look at the y's, I notice they each have a 1 in front of them. Since they each have a 1 in front of them, I can easily get y by itself for either one. I'm going to pick the linear one because it's easier without the x squared. So I can subtract 4x from both sides. When I do that, I have y equals 7x minus 4x is 3x minus 2. Then I have my other equation, 5x plus y equals 2x squared plus 6. Now, I have my system of equations. I'm going to use these two equations to solve my system of equations. I have my y here, and my y is equal to 3x minus 2. So I can substitute that in to my new equation. I have 5x plus, whenever I substitute in, I want to use parentheses. 3x minus 2 equals 2x squared plus 6. I want to simplify the left. 5x, there's an imaginary 1 here. I can distribute my 1 and get plus 3x minus 2 equals 2x squared plus 6. I have two like terms here. 8x minus 2 equals 2x squared plus 6. So now I'm going to solve this. I'm going to set it equal to 0. I can subtract 8x from both sides. that cancels out. I'm left with negative 2 equals 2x squared minus 8x plus 6. I can add 2 to both sides, and I'm left with 0 equals 2x squared minus 8x plus 8. So now I have to solve this. I'm going to see if I can factor. The first thing I notice is that I have a GCF of 2. So I can factor out that 2, and I'm left with 0 equals 2, parentheses. I can divide every term by 2. 2x squared divided by 2 is x squared. Negative 8x divided by 2 is negative 4x. Positive 8 divided by 2 is positive 4. Now I'm going to do my AC method. When I multiply the first and the last, I get 4x squared. I can use 2x and 2x, or negative 2x and negative 2x. I notice that negative 2x and negative 2x combine to give me negative 4x. So I can rewrite this as x squared minus 2x plus 4. Now I can factor by grouping. The GCF of my first 2 is x. So when I divide by x, I'm left with x minus 2. The GCF of my second parentheses is negative 2. Remember, since this first term is negative, my GCF would also be negative. When I divide by that, I'm left with x minus 2. Since my parentheses match, I can rewrite them as x minus 2, x minus 2. I cannot forget about my GCF in the beginning, so I'm going to bring down this 2. Now I set each part equal to 0. 0 equals 2, 0 equals x minus 2, or 0 equals x minus 2. 0 does not equal 2, so that's not part of my solution. I can add 2 here to each side, and I get 2 equals x. Add 2 here to each side, and I get 2 equals x. Now these are the same number, so I do not have to look at them separately. Now I also have to find y. So I'm going to pick the linear equation, and I always want to pick the equation from my beginning. So I have y plus 4x equals 7x minus 2. My x is 2, so I'm going to substitute that in. Y plus 4 times 2 equals 7 times 2 minus 2. Y plus 8 equals 14 minus 2. Y plus 8 equals 12. I can subtract 8 from each side, and I get y equals 4. So my solution would be 2, 4.